Hello, Rama. Can you hear me? Okay, great. So voice is good, chat room is good. How about my screen? Is the screen good? Aaron, can you send me the code that we created from last week for the Arduino program? It's on a different desktop in the school. So I don't have it with me. Thank you. Okay, Rawa, you're talking about your own computer, right? You're not talking about virtual machine. Is that true? Are you doing this in the virtual machine or you're doing this in a Windows 10 no virtual machine? I know this message is very exclusive to a particular version. If you're using a version that's beyond 1.8.9, it will show up. If you download 1.8.9, you won't see this message because in 1.8.9 and beyond, they changed something in the background and it has some kind of conflict. So I recommend to use 1.8.9. The Arduino application, it's a freeware you can download. You can download from Euler. And there are two files you need to download. One is from Arduino. The other one is from the board manufacturer. So install the Arduino first, then you install the manufacturer library. So on Euler, I don't recall I give you anything on Euler for this class. There's no file. I'm going to ask you to. Oh, there's a file. There's a file for the BMP. That's the file that you need to put on your SD card, so we can run the program. The color doesn't really matter as long as you compile the project. Okay, we'll figure out later. As long as you build the project, you verify no problem, then we're good. Okay. All right. So let's check the attendance. We have Rawa, Jesse, Abdullah, no, hold on, see, Abdullah Kaudi, and we have Aaron. Anybody else? Is Monica here? Okay. Right. If everybody's ready, right? So let's start. So this is a code we created in week number 1. So what it does is it detects if the card is present on your Teensy 3.5, and it will check if this file is there. Okay. Okay. Yes, Muhammad Khalid. Okay. So okay, Van is here. That's great. Okay. So we're going to continue from this example. Okay. Look at the SD card. It is a pretty sophisticated storage device because it has choose the library. Okay? If you need the instruction to set up, it's very simple. You download the Arduino application first, install that, then you download the library, install that, then everything will work. Okay? If you still have problems following the instructions, no problem. I'll find a YouTube link and you can follow that instructions. Is the voice clear now? How's the voice now? Okay, great. Let's continue. So looking at the code, we have check the card, check the file. The next step is to open the file for read. Okay. So what we need to do is we need to use this function. The function we need to use is to open the file. Okay. To open the file, you need to use this syntax. Okay. sd dot open the file name. Okay. This is the syntax to open the file. Okay. Now this step is assuming that your file is there. Okay. So if this thing fail, then there's nothing you can do. Okay. So this has to make sure that your file is there. So usually what we do is we'll put a Y1 if the file doesn't exist, like this. Okay. So if the file doesn't exist, there's no need to move forward, and you cannot open the file for read. Okay. Are we good? Please confirm yes, no. Okay, that's great. So when you open the file, you need to save it to something else. Now, file is a very complicated object or programming entity. when you save the file in Arduino, you do not save it to a regular variable like an integer. You save it to a special variable. This special variable is called a file. Okay? And usually we call it as handle of file input. Okay? So the syntax on line number 33 means I will open this file for read only and then save it to a file handle called HFI. File save. Now once you open it, if this is equal to false, that means the file did not open properly. So we need to check if this is equal to false. So if handle to file input is equal to false, that means the operation failed. And then you cannot move on in your program. Okay? If this is equal to true, that means you will not enter line number 37, line number 38, you move on. Okay? Are we good? Yes, please confirm. If you are good, we can move on. Okay? Okay, thank you. Let's move on. Okay. When a file is saved on the SD card, the file is saved on a byte by byte basis. What it means, if you have a very complicated file or Microsoft Word document, you do not save everything at once. You save byte by byte. Okay? When you save byte by byte, when you read it, you have to read it byte by byte. Okay? So the file that we're looking at right now is a BMP. So a BMP file has many, many bytes. So when you read the BMPs, you are going to read all the bytes. Okay? Depends on the size of the BMP, you need to create a buffer to hold this. Okay? Now usually when you read the BMP, you do not read everything at once. The reason is, if you have a 4K image, the number of bytes you need to read is beyond the size of your Teensy 3.5. Okay? Unfortunately, for our applications, okay, we are not dealing with 4K files. We're dealing with fairly small files. Understand? Okay? So what we need to do is we need to create a buffer that's not huge but decent size. So when you read from the SD card file, you can read a good portion of it. Okay? So in general, we are going to create a big buffer like this and give it a good size. So for example, 1000, 1000 bytes. If you say, well, I want to use 10,000, that's fine too. But whatever you're doing cannot go beyond the memory on the TC 3.5. Okay? There's really no need to make it extremely big. Okay? Because you're not going to read the whole thing at once. You're going to read pieces. So for example, right now, okay. So right now, if you look at it, it's 1000 bytes. Okay? All right. So when you read, you're going to read 1000 bytes from the SD card, from that file. Okay, but there's a catch. If the file is less than 1000, okay, well, if the file is less than 1000 bytes, you're going to have a problem because the process of reading this is 1000 bytes. Is going to go in there, start read the 1000 bytes. If the file that you're reading is only 900, and then it'll tell you the reading was not successful, okay, and then what you do, you are going to see, okay, my reading failed because my buffer is too big. Okay, that's why you need to adjust this buffer size on the fly in your application. If you know the file you're going to read it's only 1000 bytes, your buffer should not exceed that size. Okay, if your file you're reading it's only 500 bytes, you should not use 1000 bytes buffer. Otherwise, your read will fail. Okay, so if you look at the file we're trying to operate, which is the D1 sample, the size of the buff of the file is 1,202 bytes. Okay, 1,206 bytes. So if we use 1,000, you will not fail. You will continue working just fine. Okay. All right. So how do you read 1,000 bytes from the file? Okay. You use this function. Int return value HFI, that's the handle of our file, dot, dot read, two arguments, big buffer, and the size of the read. In this case, 1000. So this means you have a big buffer you're trying to read. And in this case, you are going to read 1000 from it. So this number cannot be larger than this. Usually it is the same size. So you have a buffer, you're going to read 1000 bytes and then fill it into the buffer. Okay? Then check if the operation is successful. So if RT equals to -1, means it failed. Serial.println read file buffer failed. Else serial.println read file buffer. Okay. All right. So it's either good, it's either bad, or good. Okay. So at this moment, save your projects and let's sketch, verify, and compile. Okay. Okay, you finished. No error. Program verify. Okay. Can you confirm if the program verify? Okay. Okay. SD underscore T3 A dash node. Okay. If you see a SD underscore T3 dot H error, that means you didn't select the right board. So you go to Tools, Board, you have to pick 3.5. Okay. So we have one successful, errand successful, verified. Anybody else? Okay, everybody verified? Okay, so now everybody is good. We need to plug in the board. So plug in the board. I'm using a virtual machine. You're not, so it's different. Okay, so I connect this to a virtual machine. I click OK, and I check my board. 3.5. That's good. I also check my port. Port is 3, and I'm going to program it. Press and hold the button on the board, and this is what you get. And open up the terminal. Press and hold. Release. Can you see my message? Can you hear me? If you can hear me, can you email me because I cannot see any chat? Okay. Okay, if you can see my message, can you type something, respond? I cannot see your message anymore. Okay, I can see your message. That's good. Okay. So I think I have a problem with my board. Right now, when I open up the terminal, nothing is showing. Do you see any message on your setup on the terminal? Yeah, I've tried to restart the board a few times. I'm not seeing any message. So last class we checked this section. It seemed to work fine. But right now we're just checking this section, but nothing seems to work. Not even the first section. So what I'm gonna do, I'm going to turn off and close my Arduino and start it again. It's not showing anything. Okay, so if everything works, you're supposed to see a bunch of messages. Anybody can see the message, or none of you can see the message. Okay, good info. Somebody said that as long as you have the SD card plug-in, you can see the message. Okay, that's good. So let me plug in mine and try it again. I have my SD card plugged in, but nothing is showing. It wasn't this kind of behavior last time. Okay, let me see. This is what I'm going to do. I'm going to put some delay in between all these functions, so we don't overwhelm the processor. Okay, that's good. So the problem is we are overwhelming the processor. So I recommend we put some delay in between these sections. So look at my code. So we put a delay after checking if the card is present. Okay. Then we'll put some delay after we find the file. Then we'll put more delays after we open the file. And then after read from the file, we put another delay. Okay. So if you see this, please make some changes to your code so that we don't overwhelm the processor. Okay, can you hear me, Ben? Okay, can we move on? Okay. So the next section is to print out what's in the buffer, because right now the buffer should contain a big portion of the file. Okay. So to do that, we're going to print out the bytes one at a time, one per line. Okay. Now we're not gonna do 1,000 of them. We're gonna do first probably 50. Okay. The reason is the first section of the file is not data. It's a header. So the header is going to tell you what's inside this file. Okay, like the property of the file. So what we'll do is we're going to do a loop int ii equal to 0 for ii equal to 0. II is less than, say, 50. Okay, and II plus plus. Then we're going to print out what's in the file. Okay, the syntax to print out the values is very simple. It's a serial.print. However, there's a catch. When you print out this, you can print out in decimal, octal, hexadecimal. When we work with a file at the byte level, we try to use hexadecimal instead of binary or decimal. Okay, so we're going to use hex. So this is a new program. We added this section here. So this will print out the first 50 bytes, one line at a time. Okay? Are we good? So let's verify this and upload this new program to the board and then run it. You let me know if you can run the program and seeing what I'm seeing on the screen. So Aaron is good. Anybody else? Okay, Van, what is not working? Okay. If you're missing some code, no problem. When we finish today, I'll put this on ULAR. Okay. All right, let's continue. You can see there's a bunch of ones and zeros and values on the screen. So to analyze this, we need to understand the structure of the file. Okay, so I copy everything we see from the Arduino terminal to a text editor like the Notepad. Okay, the reason we need to do this is because all these values, they are in bytes. Okay, the first 2 bytes are fixed. It's always 424D. Always. And the next one is 4 bytes. Okay, this is the size of the file. When you do application in a Teensy, you don't really care because we know that the file is small. But if you want to recognize the file size, this is the file size. Okay. Next 2 bytes. Okay. We can ignore them, and then 2 bytes, and then 4 bytes. All right. So this is constant, always 424D. This is the size of the file. You don't care. Ignore these two. Ignore these two. And this should always be 36000. Remember, there are 4 bytes. These are all in hexadecimal. So 36000. Okay. Okay. The next group, 4 bytes, 28000. Okay. This should also be constant. So this is constant. Constant. Okay. Ignore. 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 Constant. Okay. So the next four, they're not constant. These four means number of pixels, width, or pixel width. This is pixel height. Okay. Now, if you remember, what is the width of this BMP image? Can somebody type it for me on the chat? Yes. Width-wise is 16, and height-wise is 24. Okay, so to decipher this information, it's very, very important. These numbers, they're not saved in the usual way. Okay, this is what we call little endian. Okay, So what's a little endian? Suppose you have a 32-bit integer. Okay. Usually you have bytes like this. Okay. So there are 4 bytes because 4 bytes means 32 bits. So for example, I call this HHIIJJKK. HH means MS byte, and HH means, sorry, KK means LS byte. That's usually what we learned. Okay. However, in the little endian system, the 32 integer is not saved in this way. The 32-bit integer is saved as KKJJIIHH. HH is still MSB and KK is still LSB, but this is little endian. Okay? So when we do this, that means 10 is KK, 0 is JJ, sorry, JJ, and this is II, and this is HH. So the width is equal to hexadecimal 10, and there are 6 zeros in front of it. Okay? If you do the math, this is equal to 16 in decimal. Okay? And pixel height is equal to 1/8 because this, and there are 6 zeros in front of it. This means 16 plus 8 equals to 16 plus 8 is equal to 24 in decimal. So from the header, you can look at these numbers, then you can figure out the size of this BMP file, okay, without looking it in Windows. Okay. So are we clear about this? If you are, please confirm. So far, we have Aaron, we have Muhammad Al-Khaldi confirmed. Ben, yes. Anybody else? The remaining values, we'll talk about that on Thursday. Okay, because we're doing everything online, I will make adjustments to the due dates for the assignments. Okay, but so far this stream it's okay compared to the previous class. We didn't have issue with the voice, we didn't have issue with the screen, and we didn't have issue with the chat room. Okay, everything seems to work just fine. Okay, but this is very important. You need to understand how the file is saved on the storage media like SD card. Because when you read the files content, you can extract the information just from the header. Okay, you don't need to read everything. You just need to read the first section, then you can figure out. Okay? So if you look at this, 2 bytes, 4 bytes, 2 bytes, 2 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. So this is very important because it tells you the size of the pixel, the size of the width and the height. Okay, all right. This is constant. These three sections you can ignore, and these will be constants. So nothing that's interesting. And the most important is how the file is saved. It's little endian. It's the opposite order. It's not exactly the opposite order because it breaks down the integer from the 32 bits into bytes, but they save the bytes in different order. Okay, some computers or some files they use this kind of structure or this kind of format, but not all files are saved this way. Okay, just for BMP it is little endian. Okay, all right. Any questions so far? So Van is clear, Rawa is clear, Aaron is clear, Muhammad Akali is clear. Anybody else? Okay, Manny is good. That's great. Okay, if we're good, what I'm going to do is I'm going to finish today's live, and we're going to continue on Thursday. Again, because of this online delivery, I'm going to make adjustments for the assignments. Okay. Van, you have a question about the COM port. Um, when you set up everything properly, you should see under ports, this is COM number 3. You can have COM number 2, 3, 4, 5, 6, 7, 8, 9, depends on your machine. Each machine is different. Okay. If you're done, you can leave the chat and leave the stream, and then I'm going to close it. Again, I'm going to create a channel for this live stream. I'll send you a link. So when you get the link, you can subscribe to the channel and enable notification, so you'll be auto notified every time we have a live. Yes, Muhammad Akadi, go ahead. What question do you have? No, I'll make adjustment for all the assignments. So on Thursday, we'll see where we stand and then make the adjustments on that day. So right now, you don't need to worry about it. Okay, eventually we're going to catch up. Yeah, right now we're about one and a half class behind the schedule. Okay, you're welcome. So everybody, no question. You can leave the chat room. You can leave the stream. I'm going to close it. Okay. If you have a problem with the port, for example, if you go to port grayed out, it means your computer does not recognize your TNC 3.5. Okay. The only reason your computer doesn't recognize your TNC 3.5 is because the driver was not loaded into your Windows machine. Okay. To load the driver, you need to install the second file I asked you to download. When you install that file, it loads the driver into a Windows machine. Okay. Okay, I just gave the link to download the file again, and then on the page you can see that the instructions. Okay. One thing about this installation is you must have the administrative privilege to do that. If you don't, it's not going to install properly. Okay. So if you look at the page, there are many screen captures. One of them is to install drivers. Once you load the drivers, next time you plug in the board, you're going to recognize your board automatically. Okay. Remember, we're using version 9.8.9. That's the one we're using. That's one I've tested. Okay, everybody, I'm going to end the chat in live right now.